All right. Should we start? Advent of Code 2018, day 13. Minecart Madness. A crop of this size, I don't remember what the crop was, but was that the potted plants from yesterday? A crop of this size requires significant logistics to transport produce, soil, fertilizer, and so on. The elves are very busy pushing things around in carts on some kind of rudimentary system of tracks they've come up with. Seeing how cart and track systems don't appear in recorded history for another 1,000 years, the elves seem to be making this up as they go along. That's right, we're in the year 518, I think. They haven't even figured out how to avoid collisions yet. You map out the tracks, your puzzle input, and see where you can help. Tracks consist of straight paths and curves. Okay, and intersections. Really? Okay, so this is what we're going to have to figure out? Okay. Intersections occur when two perpendicular paths cross. At an intersection, a cart is capable of turning left, turning right, or continuing straight. Here are two loops connected by two intersections. Oh, this is going to be nuts. I'm just anticipating this already, and I think this is going to be nuts. Several carts are also on the tracks. Carts always face either up, down, left, or right. On your initial map, the track under each cart is a straight path matching the direction the cart is facing. Okay, so if it's a left-right cart, then it's a minus sign, and if it's an up-down cart, it's a vertical bar. I understand that. Each time a cart has the option to turn by arriving at any intersection, it turns left the first time, goes straight the second time, turns right the third time, and then repeats those directions, starting again with the left the fourth time. Okay, so we have a little rotating away. This process is independent of the particular intersection in which the cart arrived. That is, the cart has no per-intersection memory. Good to know. Carts all move at the same speed. They take turns moving a single step at a time. They do this based on their current location. Carts on the top row move first, then the second row move left. Okay. Once each cart has moved one step, the process repeats. Each of these loops is called a tick. All right, so if like cart B comes after cart A because it's lower, but then after a while they move and cart B ends up being higher on the map than cart A, then it goes first, I think. For example, suppose there are two carts on a straight track. First, the top cart moves facing down, so it moves down one square. Because all the carts have moved, the first tick ends. All right. I think I understand this. First cart moves down, the second cart moves up right into the first cart, colliding with it. Okay, so collisions are going to be important here. Here's a longer example. This is a very long example. So I just see it going through, and I'm not gonna go through these one at a time. I think I understand the rules. We move the cart along the track. We come to an intersection. Each cart has to remember if it's going to be turning left, right, or going straight. And then we have to keep track of collisions. I get all that. We'd like to know the location of the first crash. Okay. And we're going to give it as a comma-separated pair of numbers. And it's going to be like this. All right, so the first thing we need to think about is, let's get the puzzle input. The first thing we need to think about is, how do we want to represent this in memory? Get input 2018. One of these days, this is not going to work for me. Hopefully it's not today. Whoa. Oh, this is wrapping. This is wrapping, isn't it? Okay, let me look at it here then. Look at this. Oh, this is nuts. All right, I see minecarts. All right, here's one. I'm highlighting it, but it's not, the highlight isn't working well because I got that fake dark mode going on. Here's another one. So they're all over. Okay, so I think today's stream is going to be figuring out how to parse this and store it in memory. Look at all these intersections. Oh, that's going to be nuts. Okay. Tommy says, looks like the London Underground system. That's funny. Chat says, how do you parse this? Well, I'm going to parse it one character at a time, right? We're going to just go through. We're going to save the fact that this is a turn. We're going to save the fact that this is a right, left. We're going to save the fact this is up, down. And then we're going to save all the intersections. And so we're going to have 4. Well, yeah, we're going to have, well, maybe let's start off by creating the template. But I think what I'm going to do is set up an enum with 4 types, with 4 values, and then create a hash map that contains locations for everything and the type of thing that's there. So let's try that. First things first, we have to create our files. 13. This is 2018, day 13. Then we're going to do this. And then maybe someday what we'll do is work on a little build.rs so I don't have to do all this mess every single time. That would be really nice. Oops. What? Day 13. And now this says unsolved, unsolved. Perfect. All right, so step 1 is to read all the lines in. And now, yeah, like I said, let's create an enum of track type, which is going to be... Now the corner, I don't think I need to care about the direction of the corner, right? Oh, I do. I do. Because here, if we come to a corner, I was saying, well, if we don't care about the direction that the corner goes, then we could just look to see, we know we came in this way. We know the next one is down this way. We know which way to turn when we hit this corner. But I do need to, because, oh, no. That's okay. That's good. Let's see. If we know we're coming left, right, and we hit a corner, we know we have to turn either up or down. Maybe it'll be just simpler if I just remember which way the corners are. All right. We can say this is a northeast southwest corner, and this is the other direction. Right? And the other one is a northwest southeast corner. And maybe it turns out we don't even need to separate them, but let's figure it out. Tommy says corner direction. Yeah, we could do that. Let's try that. I guess how would you define that, right? Because we're talking about if we're coming west, then it wants to turn south. This is a west to south corner, but if you're coming from the north, then we want to go west, right? And if we're coming from the west, then we want to go north. So this is a west, north, southeast corner, right? Which is what I was trying to get at. Let me leave it this way and see if we can figure it out. And then we have an east-west, and we have a north-south, and we have an intersection. I think those are all the types. We also want to create a struct for a cart, which is going to have the last move it made because we have to rotate among the different moves. So last move, to move. STRAIGHT on. There we go. So we know what the next move needs to be. Should we? Oh, that's the problem with this. Impl. I'm going to do this now, even though I haven't even started writing the code yet. F and self, match self, turn left. Okay, I have to remember what the order was. Turns left the first time, goes straight the second time. All right, so we don't want left to be the last move we made. I guess we could just call it next move, right? And then we could just update it after we make the move. So after we turn left, we go self straight on, self straight on, goes to self turn right, and then self turn right, goes to self, and it just goes back to turning left. Yeah. Okay. That's done. So now we can always get the successor move. All right. So, but that's the reason I was trying to make the cart was because I need to create the cart as we parse through the data, and the current direction. We need a current direction. Oh, yeah. So maybe this would be good to have this as an enum, and from the track type we can get the next direction from our current location. Suck only on intersections. Yeah. So when you hit it, that's what the rule said. When you hit an intersection, each time the cart has an option to turn by arriving at any intersection, which is the plus sign. Intersections were defined as plus signs. Then we loop through this kind of craziness, turning left, turning right, or whatever. So enum direction. And we have north, south, east, and west. East, west. And we might have to do some messing around here. But I'm just trying to get the parsing done. And then for this, I can derive default. And this is, what's the syntax for this? Default like that? Let's find out. Well, it didn't blow up. And so that should allow us to derive default here. Actually, we don't need to derive default. We can just set it. I don't need to do it this way. Tommy says yes. Yeah, for the default, yeah. I just need to I was thinking there might be more in here, but we do need to know its position, right? Which is going to be just a XY location. So let's loop over all the lines for L in lines. Yeah, we can consume it, right? And then for C in line L.chars, like that. And we're going to, and we have to keep track of our XY location. Let mut x equals 0, let mut y equals 0. We do need to store this all in a hash set. Is there a description for this? It's just a track system. So I'll just call it something really, really boring called data. Hash map. And it's going to map a coordinate to a track type. Right, and we're going to have our carts, which is going to be, should this be like a B tree map? And then we can sort it based on or we just hit the sort each time. I'll just make a vec right now, a vec of carts for now. And so this, right, so here we'll just do x plus equals 1, and here we'll do y plus equals 1 after we push self data push. Oh, we have to figure out what it is first. Which goes here, right? We're going to push a track, or we're going to push a cart. So we can do this. If matches C, up, down, like that, left or right, then we can say match C. If it's up, this direction north, and we can do that here. And then we have the position. What else do we need? We have the direction. The next move is always going to be turn left, and the position. Okay, so now we can just say self carts push, and this should be insert. And we're going to create a new cart. Next move is going to be turn. Is it just, yeah, it's just move, turn left. Let's put this on a new line so I see what I'm doing. Direction D, dir, and pause is going to be XY. We are going to need to put this here and say panic. Someone broke the Rust compiler. And then change all these south, east, and west. Right? West is going that way, east is going that way, and south is going down. This looks pretty good. I think we're getting there. Else, it's got to be a track type. Or it could be a blank space. So, yeah, else match C. And we're going to do, like, this is a vertical bar. And let's just split this up here so I can see what I'm doing here. Data.insert x comma y of track type north south. Right? This is all we need to do, right? Data insert xy track type east west. Tommy says, did you study computer science? I did. Back a long time ago. We'll do this. XY track type. And this is like if you're going west, you want to go south. Right? So this is a northwest, southeast corner. Right? And if you're going east, you want to switch to north. So that's what I'm looking at here. If you're going east, you switch to north. If you're west, you go to south. That's the way I'm reading it. Like this. Now it's not going to line up anymore. Oh, this should all be self. Track type northwest, northeast, southwest corner. And then intersection, which is this thing. Self data insert xy is nert. There we go. Track type intersection. And then anything, space is allowed, and we'll just ignore it. And anything else is panic unexpected input C. Right? Now let's zoom out again, and then we need to increment X. That doesn't happen anymore. Method suck is never used. Enum track type is never. Okay, I'm not going to worry about that. Let's see if we can at least parse the track info. What did I do wrong? Oh, I forgot all of my closing. That's what Tommy was asking if I studied computer science. Don't you know you have to close your parens? Oh, you can't. Okay, sorry. My C brain was making a break for it. There we go. You can do that in C. We don't have hash map. And what's this other thing? Dir is not found in scope. Oh, because I forgot to set it here. Let dir equals. There we go. And now this match arms have incompatible types. Oh. Because these are all what? Unit types? Oh. They return an option of track type. Got it. Okay, so we'll just pull it out. Oh, how do we want to do this? I guess, you know, it's kind of annoying. Well, one thing that's annoying is it's not lined up. But we do need to do this then. Oops. Let's try again. Right? And then here we change all these commas to semi-close. Right? And that just spreads it all out, which is unfortunate, but that's what you have to do to get that to build. Okay, so the parsing worked. It took 11 milliseconds. And Tommy says, imagine using language as parens. It's crazy. Scoop says, let underscore equals blah. Yeah, except that would... I think that also requires... Well, let's try it. I mean, I'm willing to give it a shot. But I think that also requires the braces. Yeah. So that unfortunately that won't work. I wish that would get everything onto one line, but oops, went too far. And Scoop says, boo. Yeah. Well, we should submit an issue to the Rust committee, Rust language people. Because I don't care about these values, and in C you could just cast it to void and make it go away, and then that way we could have done it all in one line. But this is fine. This compiles. Let's print out like the first chunk of the hash map and see if we have something that's visible. What is the equivalent? I was about to say, what's the equivalent of implementing toString? Because my brain was on Java yesterday evening. But it's obviously just a display trait. So how do we implement display for track type? I should put it down there, right? And display doesn't exist. Standard format display, yeah. And let's do that. And it's just write bang f of match, right? Match self. And we can grab all these guys. Put those here. And I think I can just say self right here, right? And northeast, southwest corner means if you're going east, you turn south, which is this character. I don't need the brace, I don't think. And then that means this is the other one. And east-west is just a minus sign. And then north-south is a vertical bar. And then intersection is a plus. Okay. And that doesn't like me because I got to close that. There we go. The way I tell if I have a syntax error is I try to hit Rust format, my hotkey for Rust format, and if it doesn't format, there's a syntax error somewhere. Pretty clever, huh? All right, so we're going to just look at the first maybe 10 lines, 15 lines, right? Y in 0.15 for X in, and we're not going to do the thing, I forget how big this window is, but let's do 80 characters long. And we can just say print bang this self data get I was doing XY, wasn't I? I should be doing Y. Oh, it doesn't matter. All right. We do that. We do a print line. And we do that. And we'll see what it looks like. Option. All right, I got to do unwrap. Oh, that's going to panic because I don't have anything for non-existing entries. Scoop says a space goes to none. Oh yeah, that might do the trick, right? Because then it would have to be. Yeah, I think you're right. Let's try that. I'm gonna have to fix the panic, but let's. I have to change all of them. Unfortunately, you can't just change one and see if it works. Now I hit format and it doesn't like that because of this comma. There we go. Now let's see what happens. Expected unit found option track type. Perfect. Thank you, Scoops. That was awesome. Tommy says / and backslash are equivocal. It's about the context. It's important to how you moved before. Probably. You're very probably right. But since I haven't implemented the algorithm to do the ticks yet, I don't know how I'm going to do all that stuff. We do know the cart's direction. The thing I'm getting hung up on is that, if we're here, say, you can barely see that highlight, but there we are. And we're moving to the west. So we do another tick and we're here and we're moving to the west. Now we come to this thing here and we say, okay, we were moving west. Now we want to either turn, if we just make a single corner type, we have to say, well, we're either going to turn north or south, which is fine. But it means, like here, if we're moving west from here, we go here, we're going to say, okay, if we just have a generic corner type, we know we hit a corner, so we're going to turn from east to either north or south. If we look north of us, I guess we can say if north of us is an east-west thing, then we can't go north. If south of us is a north-south thing, or then we can go south. So we could go either to an intersection or to a north-south piece. Now, what if there's an intersection up here? I don't know if that's even possible. And that would prevent us from being able to figure out which north. Tommy says, what I meant to say is the top left corner is the same character as the bottom right corner. Yes. Yes, that is true. That is true. So if you're coming along here, you go south. But if you're coming this way, then you're going to go north. Because it's the same character. You're right. Horrible fart. Really? Thank you for the follow. Unfortunate username. All right, let's see if we can do this now. If we can just say if, we can say if let some track. So it's a little harder than I wanted it to be, but we can do this. Is this, then print bang track, else print bang space. Right? We can do that. Oops. Why did we only get one line? Oh, and then everything else is blank. Oh, did I forget to increment something? No, I got that y plus equals 1 for each line. This looks like just this first bit here, right? And then why aren't we getting any of these? Okay, I'm glad I did a test. I don't set x to O. Thank you. X to 0. You're absolutely right. This should be in here. There we go. Yes, this looks all correct. Okay. I mean, it looks legible. I didn't compare it directly for the, but this looks right. This looks correct. Yeah. Let's call that a win. Let's call that a win. So we're now able to parse. Thank you, Scoops, for that. I appreciate it. We do have a whole bunch of warnings, but I'm going to ignore the warnings. Git status, git add source, git commit -m 2018 day 13 parsing. All right. That took us only 50 minutes. Not bad. Scoop says unwrap or space for the space. Yeah, you're right. You're right. When you're right, you're right. 1813, right? That's definitely better. Print bang. This. Unwrap or space. I missed this. And I forgot the comma here. Up. Oh. That's... Maybe this should be okay or. I thought unwrap or would work. Self data get. Oh, you're right. That thing goes there. Expected a track type. So that means we have to create a track type of none, or we'd have to say because data get is going to give us a track type. It's not going to give us the display. Scoop is saying impl display for option track type. We could definitely do that. There we go, option. And then we have to sum all of these. And then do a none space. Option is not defined in the current crate. I didn't realize you had to do that. Oh. Right, option is not defined in the current. So you can't impl. One of these two have to be defined for your own thing. So I can't do that. That's too bad, because that would have been a clever workaround. Let's put all this back. Scoop says again, boo. No, I'm glad I'm trying it out though, because it's let's put all this back here. I didn't undo far enough. Because that's helping me learn. So I do appreciate it. All right, so now the next thing you do is implement tick. Now that we have this, if I do this, is it going to complain that display is not used? No, it doesn't seem to care. Okay. So we just have to obey the rules for every cart. And right now the vector is sorted by XY location. So we can just run one tick. Should I do this as test input? I think I should. So I'm going to grab these lines here as test input. Oops. Let's just grab that, copy. And Tommy says, imagine this is possible. You download crate and somebody's overwritten the string display. Yeah. I understand the reasoning behind it. It's just that, you can do so much with the impls, but then things break down. I could create my own trait, which just reflects onto display. And then it would have to go through those two steps. Right? I could have a trait disp, and then that would call display for the track type. But I'm not going to go there. Where I'm going to go is here, cat into a test input. Put that there. And then I'm going to change my read to read the test input. And then we're going to just run it real quick just to make sure we have the test input. Oh, I commented out the code that dumps it. Here we are. Okay, so this is our test input. We don't have any of the track data yet, but we can print that out too for v in our cart in self carts, println cart, and I'll have to import debug for all of my little fields. Right. I'll put it there too. Why not? Couldn't hurt. And now, so we have two carts. The next move is going to be to turn left. The direction it's facing is east, and the position is at 0, 2. That's this guy, right? He's facing east, and he's at 0, 2. This guy's facing south. He's at position 9, 3. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Oh, that's a 0, right? 0. Oh, I got thrown twice. Okay, that's good. So I think we're parsing that correctly. So now all we need to do. Tommy says there should be private trait overrides. Yeah, a lot of good ideas here. Unfortunately, I'm not going to be able to I don't know Rust well enough to be able to support it, submit an RFC. All right, so let's get rid of this. I'm going to leave that in there just for now. And then what we'll do is we'll implement a tick and run a single tick and then print out the result. Yeah. Actually, so I want to leave the cart in there. Then we want to say self tick and then print the carts out again. Right? That's what we want to do. The track doesn't change, but the carts change. And we want to make sure that when we're done, the carts end up being sorted correctly. First by Y and then by X. And we can do that. So let's write a tick function. Doesn't return anything because it's just going to update the carts. That's all we care about. So we're going to do for each cart, we'll create a new vector, let result equals vec new, and we can just push that on there and then we can be able to sort it. Self carts, right? We're going to look at the direction we're going to go and we're going to move one position in that direction. And then we have to decide, are we on an intersection? Or are we on a corner? Where did we end up? Oh, we need to look in that direction first, I think. Do we? Or can we always assume that the direction we're facing is going to be a direction we can go? Yeah, let's assume that. And we'll do any changes to direction when we hit it. Okay. So we're going to have a new XY location. Let XY equals. Oh, first we have to get the track that's at that location. We're going to say let track equals self data get. No, I'm completely wrong. First, we want to move to our new location. So we're going to say match c.dir, and it's going to be something like that. Any code following this expression is unreachable. All right, well, let's get rid of that. I was hoping you... Oh, there is no... What? I called it direction. Okay, that's fine. There. Now can I do fill match arms? There we go. So if we're going north, obviously it's x comma y minus 1. South is x comma y plus 1. And Russell will add all the spaces I need. And then east is going to be x plus 1 y. And then west is going to be x minus 1y. There we go. So now we want to get the track. Track equals self data get xy unwrap. We're going to assume that there's a track piece there. Now we have to make a decision. So we're going to say match track. If it is carry on, right? So if it's a minus or it's a vertical bar, not that, this thing, then we do nothing. We've moved and we're good. If it's this corner, then we have to make a decision about which way to turn, our new direction. So I'm going to say let direction. There we go. And so we're going to update our current direction. So we're going to say match whatever our current direction is. And we're going to change it. If we hit this and we were going north, that means we want to go west. If we hit it and we were going south, our new direction is, oh no, if we're going north, we want to switch to east, right? Because this one's west. If we were going east, then our new direction is north. And I can totally see this getting something wrong here and just messing up the entire. If we're going west, we want to go south. Oops. All right. So we just say direction equals this. And this might have to be in braces. I don't know. If we hit this thing. Oh, wait, I'm not. What am I doing? I'm supposed to be matching on the track type, not on the characters. Right? Match track. So this is track type east-west or track type north-south. Do nothing. If it's a northeast southwest corner, right? And then if it's the other direction, oh, let's put this in braces just to be on the safe side here. If it's the other guy, northwest southeast, I should put a comment saying what character is that we use that for, right? Right, because this is the northwest southeast corner. Oh, do I have that wrong? I have this backwards. All right, one more split, and then we'll do this. And this character is forward slash and backslash. There we go. So if we're going north and we hit a backslash, we want to go west. If we're going south and we hit a backslash, then we want to go east. I keep flipping the O and the I when I type direction. And the same thing with this, we just flip these around. This should be south and north, right? And then, oops. And missing match arm intersection is not covered, right? So let's do that next. Track type intersection. I did it for that too. I guess it's just the TION that I can't do. So if we're at an intersection, now we have to just use our next turn value and update next turn. So if our last turn, but we have to know it turns left the first time, goes straight the second time, and then turns right the third time. I guess intersections always have all four directions available to them. So if we're at an intersection, we're going to first figure out what our new direction is going to be, right? Which is what's an easy way to do this? Because I don't want to have to write, if we're going east and we're turning right, then it's south. If we're going east and we're turning left, then it's north. If we're east and going straight on, then it's east, right? But that means I would have to write 3 for each direction that we're currently going. I can write a turn function on direction. I think that would help. I can say direction equals direction dot turn from turn. I don't have a next turn in there. Next move. Yeah, because straight is not a turn. So let's call it move. And we'll give it a move. Next move. And then we can say next move equals suck. Next move suck. Successor for that. Oops. Right? And then down here, after we're done with all of this, we're going to say result push, and we're going to create a new cart, I guess. Or should we update the carts in place? I mean, we could do that rather than allocating a new cart each time. And then we can say c.direction equals direction, c.next move is equal to next move, and then c.position is equal to xy, right? Why is it still saying that? All right. I don't know if I want to run this yet. I guess I do. Couldn't hurt. On line 19, it's saying what? What's going on here? I'm on line 19, And it doesn't say match dir. Oh, there must be a right, this should be c dot x and c dot y. Pause. Wow. I'm losing it. And I haven't even been streaming for 2 hours yet. How's that? Oh, one more. No, here. Oh, and these are zeros and ones. There we go. We're getting closer now. Okay, now turn. There's no method name turn found in direction. Let's add that. So this is going to be the complicated thing. So if we are impl turn direction, fn turn m move. This is the thing I wanted to try to simplify, right? If we are going south, if I say, oh, this should have a self. So this is going to generate a new direction each time, but that's fine because it's just an enum. Let's say we're going east and we're turning north. I see this is what I don't want to do is saying match self north, match, oops, not self north, match self, self north, match m, right? And then I say move, turn left. So our new direction is self. If we're going north and we're turning left, our new direction is west, right? Straight on means we're going to go north, and then move, turn right is self east. Do I write these 4 lines for each direction, or is there a simpler way to do that? I guess I'm going to just do it. Okay, so if we're going south and we turn left, then we end up going east. And west. Yeah, there's probably a better way, but I'm not thinking of it right now. If we're going east, we turn left, that's north, which means this is south, and this is east. And then finally west. If we're heading west and we turn left, that's south, west, and north. Right? And now, at least the logic is hidden behind that. I could also probably do this here, inside direction. All right, let's see what happens. Oh, right. I'm just updating in place. And then after I do the update in place, I want to say c.sort. Does there exist a sort function on vec? Oh, self carts. C is a direct reference into the cart. Yeah. So then I can say sort here. Sort by key, which just takes a function. The sort is staple, and O of m times n log n. So what argument does it give here? And does it sort in place? It gives a cart. Okay. So we can compare. Oh, in order to do that, we'd have to know absolute values for x, y. If I say sort by, does it give us pairs? Yes, so now we can compare carts. All right, so we can say, and it's expecting us to return an ord, I think. Let's find out. sort by partial compare. Okay. Okay, I can do that. Cart 1 and cart 2. And we can just say if cart 1 pos 1 is equal to cart 2 pos 1, right? If the y's are equal, if on the same row, we're going to compare by, oh, I haven't done collisions yet. It's going to be C1 dot pos 0 dot partial compare to C2 pos 0. Oh, okay, I can do that. And then this is going to be by the ones. That's all we need to do, right? Doesn't like that. Expected ordering found option ordering. So can I just do compare directly? Is that what I was looking for? Yeah. Consider borrowing here. I just want to make a copy of it. And we can just make it copy clone because they're simple enums. Oh, just like that. There we go. All right, so we did something, but oh, that's in check. How did I switch over to check? Let's do run. All right, so it did a move. It started here at 2, 0, and 9, 3, and was going east. So now when x3, 0, and it turned, didn't it? Was that what it was meant to do? Yeah, because it reached an intersection, and the first intersection it needed to do was turn left. If we're heading south, its new direction is east, and it'll go straight on the next time it hits. Oh, okay. All right. I think we're good. Let's see if we can get these things to collide. And maybe what I can do is I can print this out. Printing out is going to be a little harder because unfortunately I have the carts in a separate location to the track. So if I wanted to print out the full track, that's going to be a little difficult. But I think I'm making the step in the right direction. SMAP says, now to make them crash. Yeah, let's make them crash. How many turns does this take? Because then I can just do a for loop instead of having it infinite. It just says for a while. I was hoping to say, after n turns, it crashed. And it crashed at 7.3. Okay, yeah, let's make them crash. Let's ignore this bit here. And I can just say for underscore in 0 dot dot. Let's give it 100 tries. 100 goes. Self tick should return how many carts there are left, maybe? Oh, we know how many carts there are left by just looking at the carts vector. Okay. But it should return. Oh, in a tick, you could have multiple crashes, couldn't you? I mean, because, if you look at this, what if multiple ticks cause a crash? I mean, sorry, one tick causes multiple crashes. So what we can do is have self tick return a vector of the crashes. So what we can do is compare it. In our sort by, oh, we can't extract data though. I wonder if we can just have a hash map. Can we modify things in here? Let me try it. Let mod hash set new crash equals hash set new. And then we can say, Let's do not equals, right? If these are not equal, then we'll compare these. Else if c1.pos.0 is not equal to c2.pos.0, then we'll compare these. Otherwise, we have a collision. And because the way sort works, we could end up with multiple collisions. Oh, we still want to result with a compare. Okay, let's do it this way. Oops, actually I want that. But I want to check here before I do it. I want to say if. So c1.pos.1 must be equal to c2pos1. So c1pos0 is equal to c2pos0. I'm going to say hash set crash insert c1. Crash insert c2. Both those guys crashed out. Will that work? Will it let me do that? The trait-bound cart hash is not... Oh, I have to make this hash. Can I just throw a hash on here? And then on move and on direction? Cart EQ is not satisfied. I need partial EQ. Oh, and also on the cart. Still. Oh, I need EQ and partial EQ. Okay. Gentle Automaton, thank you for the follow. See if that works. C1 escapes closure. Oh, now I have to clone them. That's unfortunate. Exton1, thank you for the follow. Welcome. All right, so I guess what I can just do is I can just do it the dumb way, right? Instead of doing all this, let's put this all back. And I'll leave the hash and the EQs and whatever on the other things. It doesn't hurt. What I can just do is loop over. Scoop says, can you do the mute trick? I'm not sure what that is. The problem was that I was putting a copy, or I was trying to reference C1 in two different places. So I would have to clone it out of here, make a copy of it and stick it in the hash set. Or make the hash set. Oh, maybe that's what you're saying. Make the hash set references. Maybe I can do that, Scoops. I'm going to cheat though. And just do a simple for I in self carts len, right? 1. And let prev equals 0. Okay, so we can say if carts self carts pos equals self carts of I. Oh, we're going to do it even differently, or there. If these two carts are the same, we're going to take that cart off of here and move it onto a crash list. Let mut crash list equals vec new. Right? What we'll do is say self let cart equals self carts remove I. Oh, what if there's multiple? We have to remove both prev and I. But if the next one along is equal, we have to remove that one as well. Yeah, okay. So this is where I just hash them up. Can I do that? Why is this hard? I mean, this shouldn't be a hard problem to solve, to see if two things have the same position. And because they're sorted, they should be okay. Yeah. Let's do that. Yeah, we can just have a result and say, you know, we just don't put prev or. Oh, no, we can't do that because then. Okay, so we can loop over the vector. Let mut count equals hash map new for C in self carts count dot entry of C dot pos insert or what's a or insert? That's it. Or insert 0 plus equals 1. There. That should work. Right? And that counts up the number of carts at each location. We still need to return crash list, LSIT. There. So now we need to filter through the hash map for any value that's not equal to 1. Okay. For C in, I'll call it count, didn't I? Count iter filter C, or C dot, wait, is this a tuple? It is. C dot 1 is greater than 1. Right, and now this is a cart. Oh, it contains the whole thing. Okay, so cart and count. Oh, this position. So now we need to find this position in the array of carts and remove it. This is a little sloppy, isn't it? For I in let mut I equals 0. There's got to be a better way. For I while I is less than self carts len, if self carts I dot pos is equal to C, then self carts remove I, else I plus equals 1. Ugh. Expected reference to I32 found I32. Okay. And we got a panic on line 29. It's trying to go to a cart, trying to go to a location that doesn't exist. Okay. So that means we have to work our way through and print out the carts each time here. Oh, maybe if crash list.len, if not, crash list is empty, and println crash list. How's that? Yeah, I don't know if I'm going to be able to get this done today. Wait, I thought there was an is. What is it? This is a vec. Oh, yeah, it's because I didn't actually return that vec of cart. So we have to add it to our crash list, right? Let mut crash list equals vec new crash list push that, and then crash list. Yeah, that works. Right, and so it didn't find a crash, right? Because this would have come out. Else println self carts. Let's see how far we get. We got a few. Println. Let's put a little barrier between each move. How do we determine, because this went 1, 2, 3, 4, 5, 6, 7, 8, 9 moves, and then on the 10th move it failed. So here's our initial setup. 1, 2, 3, 4, 5, 6, 7, 8, 9, and here's where it failed, 10. It failed here. It made this move here. Let's see if the carts are in the right locations. It's hard to tell. Y is 1 for this guy. Yep. And position is 10. Yeah. And he's facing west. Facing west. And this guy is facing south. At 9, 2. Oh, he's in the wrong spot. Oh, no, up here. 9, 2. Yeah, that's correct. So these things are correct. I don't know about the next move, but the direction's correct and the location's correct for this guy. So we have to figure out what piece of track we're trying to grab that doesn't exist. Because that should never happen. We should never go off, right? Because if this guy's going west, there's definitely a track to the west. If this guy's going south, there's definitely a track to the south. So let's go over here and figure out getting track from X, Y. How's that? And we can take a look at where it's trying to get the track. 9, 3. One, 2, 3. There's a track right there. Right? It's getting this one and this one. 9, 1 and 9, 3. Okay. So let's print out the track again. I think I still have the track printing code. Yep. Let's move it up here. Oh, I got them all backward. That's why. All right. I must have been inconsistent in my determination of the, or maybe when I switched these, I got it wrong. Let's find out. Let's close that window, split this, and we know northeast southwest is a /, and northwest southeast is a \. Or maybe I just printed it out wrong. Northeast southwest is, oh, this is what I'm doing, printing this wrong. Okay. Like that. Smab says, did you remember to add track in there? I think so. Although I can see here it's a missing track. And there's a missing track here. How is that even possible? I must have messed up in the parsing then that I didn't even notice. Is there something, someplace oh yeah, look at that. I forgot to, I didn't put the x plus equals 1 outside the, it's because I'm an idiot. Oops. No, this should be, wait a minute. Oh, my brain is messed up. It just, yeah, so this is in the right spot. Right? For some reason I thought this was on the if instead, but it's not. It's on the 4. It doesn't match this. So we come down here. If it matches the forward slash, I'm just going this character by character. Matches the forward slash, we insert that thing. We then increment X and we come back to the next character, which is a minus. It comes here. We insert the east-west. If Y is equal to 0, println C. It's reading it, right? Oh! Smab, I'm sorry, I missed your first statement there. Isn't that space where the first card started? You're right. So if we see one of these, we need to do the inserts for each one of these. And so these become north-souths, right? Semicolon here, and this here, and this gets a little more complicated, right? But this is basically what I'm thinking. Oops. All right, this is a north-south one. And then we have east-west ones. Sorry, Smab. If I'd been paying attention to chat, I would have gotten the answer a lot faster. Okay. And that's why the cart position was missing. Come on. Here. There we go. All right, now that fills it in. And now, oh, we ran it 100 times. But we did, at 7.3, get a collision. Yay! Exon says, how long do you normally stream? Usually about an hour and a half to 2 hours, because after that, my voice starts to go, and then my brain also starts to go. But this is good news. We have a collision. But I didn't see it print out. And it did do this, but didn't print out the collision. How come? Did we not get a collision list? A crash list, rather? So let's not print out the carts anymore. And I don't need to print out these things anymore. And I don't want to print out the track anymore. Let's just try to figure out why we weren't able to detect the crash. Or maybe we were and I just lost it in the... Yeah, I don't need that. Okay, so here's the crash list right here. So this is the first location that crashed. I guess we don't need to insert every track that's equal. Right, so instead of doing a vec track list, we can do a hash map of the locations, because that's all we care about is locations. Hash set. So we can just say let pause is equal to self carts remove dot pause, right? And that's our XY thing, and we can just say crash list insert pause. Right, and then instead of returning a vec, we'll just return a hash set of I64, right? And I do that, and we should get just 7.3. Okay, and that's all we're looking for, is our answer is 7.3. And that's all we care about is the first crash. All right, so I think we're good. We're almost ready to finish up part 1. We can say loop. Boom. If crash list is not empty, then we're going to say, is there a pop on that? Crash list pop. That does not exist. Iter next. Unwrap. Return crate output that. See if that works. I64 cannot be formatted with the default formatter. Format bang. How's that? 7.3. Oh, and it's in parens. But I want the output to be exactly. Okay. we can do this. Let pause equals that, right? And then we can just say output format x comma y. X comma y, x comma y. 7 comma 3. Okay. So should we do it with the real input now? All we're looking for is that first crash. All right. So let's do it with the real input. Moment of truth. Drum roll, please. 7387. Let's see what this gives us here. That's a shame. That is a shame. How do you even debug this? How do you begin to debug it? I wonder if I have XY backwards. No, I don't have XY backwards because it's, I got 7 comma 3 for the test input. What could be going wrong? We could not be maintaining our turns correctly, but that would have been here. Oh, you know what? I never looked at. Wait a minute. Do you have to care? Do you have to look like? If you're going east, this is always going to go south. Yeah, you don't have to care about. SMAP says, "Are your carts always moving in the right order?" That's what the sort routine is supposed to do. Right? We sort the carts after we're done modifying everything. We resort them, hopefully in the correct order. But that's certainly something we can print out. Let me see how many moves it takes before I start dumping tons to the screen. 266 moves. Scoop says, I think you need to check for a crash in the middle of moves, not at the end. Oh. And then, but you still need to finish the move, right? Somehow. Let's take a look. Let's see what it says when they crash. What does it say about crashing here? Or maybe... And usually he has... So the first crash will be in the first... Let's find out. Let's find out what's in here, right? I mean, usually he has stuff set up so that you get one answer. Let's find out what's in this crash list, because, maybe we just need to sort it by... No, there's only one crash in that entire thing. Oh, Scoops, you got a good point. Yeah, if cart 1 is moving east and cart 2 is moving west and they are right next to each other, first move will crash. But the way I have it right now is that they do pass through each other. You're absolutely right. And of course the test code didn't have that. So what I do need to do then is have a list of all the positions, and then at the end of our movement routine, we look to see if we hit another cart. So that should be fairly straightforward to set up, right? All we need to do is have a hash set of all the positions, right? Let's say but we don't want to crash into a ghost, right? I was going to say, well, we'll save all the positions, and then as we move each cart, we can, I guess what we can do is remove the cart from the previous positions. and then check to see if there's any collision. So the previous position would be cart, self carts, iter, map, c dot pos, hash set from iter. I think there's a from iter on hash set. Yeah, look at that. Yeah, and then added it back in so it has your new position. Okay, so we're just looking for, but that'll help us determine the crashes, and then we can go through. Okay, let's see if we can at least get this part done here where we can detect the crash, and then previous position I'll leave. We can insert ourselves, but we also have to destroy the cart that we crashed into. Oh wait, what I'm in the parse routine, not in the tick routine. I should be in the tick routine. So I was thinking is what we grab all the current cart positions here, and then we have a crash list, and then we start here for this cart. If crash contains c.pos, then this cart is crashed also, and we remove it from our list. Right. And down here, so maybe we don't want to intermute. We want to actually consume the carts. That way we can move them in. Oops. We can move them to a new list. I do this. Right. cpos blah 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 blah, and say, oh yeah, but what if a cart crashes into them while they're in the new list? Okay, that's not gonna work. I only need to return the first crash. Yeah, I'm just thinking about what part 2 might be. Right? But you're right. Let's just worry about part 1. Let's absolutely just worry about part 1. So now we can say if prev pos contains xy, right? Then we're going to return xy, and that's what we'll return is the tuple that contains the location of the crash. Otherwise, what we're going to do is going to say prev pos remove cpos, prev pos insert xy. And get rid of that. And now this is no longer a crash list. We're going to return an option, obviously. Obviously, I don't know why you wouldn't want to return an option here. Come on. I'm trying to type faster than I think. And then tick is going to have to say if let sum pos is equal to self tick. Right? How's that? Sum. Hash set. What's this? Oh, it needs to be mutable? No? Well, it does, but what am I doing wrong here? Type annotations. Oh, we can't tell? This can. Oh, I just need... No, a hash set. This is not a hash map. Why can't it infer that type, though? How about 4122? Should we give that a shot? Hey! Thank you, Smab. Thank you, Scoops. Very much appreciated for all your help on that. That took a while, but this is good. This is good. I'm really happy. This is ecstatic. It makes me ecstatic that we got this solved. And it took me 2 hours. I don't have time for part 2. So I'm not going to peek at part 2. I'm not going to look at part 2. We'll do part 2 in tomorrow's stream. Because I have no idea how long that's going to take me. It definitely won't be, just do this. It's going to be something that it's even more complicated somehow. All right. So let me get, I'll leave this code in here. The comment code, because I might need it again. I think everything else is clean. There's no printlns except for that. Good. Okay. Git status. Oh, we're going to have to check in with Clippy. Oops. All right. Really quickly, let's fix the Clippy complaints here. Variable X is used as a loop counter. You're right. See, now if I'd done that, I wouldn't have messed up the whole X thing a lot earlier. Right? I can just AXC lchars enumerate. That goes to that. And then for X, we can get rid of the X plus 1 down here. And same thing with this. YL and lines enumerate. And that gets rid of the y plus 1. And now there's an error. Iter. Oh, now that blows everything up. That blowed everything up. I guess I could make these, change them. I was doing I64s because I was figuring I'd be doing subtraction and multiplication and all that kind of jazz. Let's change all the I64s to usize. There we go. Now Clippy's happy. Let's see if we still get the same answer. 4122. Yep. Very good. Yeah, I'm not Uncle Rogers, Ackerhan. I'm just a regular, ordinary American. Git add, commit -am 2018 day 13 part 1. That was actually a lot of fun, even though it took me 2 hours to do it. Normally I can knock out advents of code faster, but there's a lot of setup here and a lot of trying to figure out the right model. And where we left off last was the exciting time of Advent of Code 2018 day 13, where we got part 1 done. And something I just realized this morning was that now we have 25 stars. We're halfway through this event. We did have a solution for part 1, and we didn't even take a look at part 2 yet. So as soon as I click on this 13, it'll show, well, we'll have to scroll, but we'll show part 2. Let's pull up the code before we get too much further and take a look at what we did. Right, so we have this tick function, which moves the carts along. And as soon as there is a collision, because that's what part 1 was all about, was finding the location where the first collision occurred. So if I just pull that up, it says 4122. And looking at this now, I realize that we don't need to wait until after we do the track and stuff like that. We don't have to do all this work. We can just look at what's the next position we're going to be at. And if there's already a cart there, then we can stop. So I'm going to just delete that and put it up here. Like that. So now, oops, I guess we can separate that out. So now we should be able to, it should have the same result. Right, because all we did was, break out of that earlier. Track isn't going to change, so that we don't have to worry about that. Here's where we move the cart to the new location. I don't know if there's a way to assert that remove. One of the things that's neat about, if I say prev pause, I can do this, and oh, it's the only match. I can pull up the help if there's multiple matches, right? And I can see the little help down below, right down here. It'd be nice if there were a hotkey to say, pull up the help for this guy, even though I already have him. There should be a Rust thing for that, a NeoVim thing for that. Then we sort the carts because we have to always process the carts in order. And then, what was this? Oh, this was a failed attempt at trying to figure out the crashing. Okay, so we actually don't need that. And then return none if nothing crashes. Yeah, that's right. Okay, so this should still work. Okay, I think that's a little cleaned up now. We have a little printout thingy just to print out some of the track. I don't think we need that anymore, but I'll finish part 2 before I pull that out. Okay, so let's call that just cleanup. Git diff. Let's make sure I didn't break anything on Clippy's side. Oh, the other thing was that Rust came out with a new version, 1.74. Git status. So let me commit these changes. Some cleanup. And then let's do a Rust up update. Git commit -am new Clippy lints from Rust 1.74.0. All right, so that was a warm-up for the warm-up. Let's take a look at Advent of Code 2018, Day 13, Part 2. All right, what do we got? Part 2. There isn't much you can do to prevent crashes in this ridiculous system. However, by predicting the crashes, the elves know where to be in advance and instantly remove the 2 crashing carts the moment any crash occurs. They can proceed like this for a while, but eventually they're going to run out of carts. It would be useful to figure out where the last cart that hasn't crashed will end up. Okay. After 4 very expensive crashes, the tick ends with only 1 cart remaining. Final location is 6-4. What's the location of the last cart? At the end of the first tick, where it's the only cart left. All right. So this is good. Let me use this as test input, because here's the thing. The way I wrote this is that as soon as a crash occurs, we stop. We stop doing the tick. But I think what we're going to have to do is we're going to have to continue with the tick, finish out the thing, and then we can still return the position of the first crash, but we have to be able to continue so that we can continue running the quote-unquote simulation until there's only 1 cart left, which probably means we want to slowly pull carts out of carts. Mirhurst, thank you for the follow. Welcome. Right, so it means what we have to do as we're going through the tracks, and as things crash, we have to pull them out of the carts list. And then once there's only 1 cart left, then that's going to be our answer for part 2. So we can't just return here. What we need to do is keep a list of all the carts that have crashed. Aiden Amvi, thank you for the follow. Okay. I'm trying to think of how we're going to do this. We can keep track of the index of the cart that's crashing. right? This will give us the cart's index as we crash. I guess what we can do is, I mean, the previous position contains a list of where the carts are crashing, so that or the carts are, so we know if 2 of them crash. But we'll need to store the cart that's there so that when the second cart crashes into it, it can say, oh, I have to remove you from the list as well, right? So I think we need to change this to a hash map. And have it, oh, then we can't do from iter, can we? There's got to be a better way. Unless you can do it from tuples. Iter, maybe we can do enumerate. I don't know. I'm just making stuff up now. And then this should be, and so we can just return the pause and a, oops. Right, this is the index and the cart. Let's just use the same thing, and that can be the index there. And now we have a syntax error because I forgot something here from iter there. Yeah, I don't know. Let's see if that works. Oh, it won't compile down here now, right? Because this shouldn't contain it. Oh, yeah. No, that's right. If it contains this, we can say instead, we can say if let some cart is equal to prev pause get xy. That means we crashed. Not only have we crashed our current cart, which is an I, but we've also crashed cart. So let's make a list of all the carts that have crashed. Let crashed equals vec new. Why did I capitalize the N? And we'll just push those on there. Oh, but we might push it multiple times. Okay, we'll get a hash set new. So we'll just say crashed. No, crashed, push, insert I, and crashed, insert cart. Now, the thing is, if we're doing part 1, we want to return let first crash equals none. We want to return the cart that crashed, the location of the cart that crashed. So we can say if first crash is none, then first crash equals, and we're just going to say some xy like we did before. And then we'll just keep going, I guess. And then here at the bottom, we'll just return first crash. And let's see if this, before I save it, let's go back and run it. 4122 is our answer. If I run it again, is it going to work? No, it's not even going to build. Oh, because I forgot to put this thing here. usize. And I did that wrong completely. Okay, we're going to deref that to get the usize in there. And then prev pause insert. Oh, we no longer want to do that. We're going to remove cpause. Oh, and this should return the value, although it is the current cart, right? So we can just do that. First crash. Oh, did I forget to make it mutable? I did. I wonder if the hot thing, change it to be mutable. There you go. A hot fix. Okay, so we're still 4122. But now, technically, we should be able to, and I'm going to quit out of Bacon so I can run it in the terminal and hit Control-C. We should be able to run part 2 until there's only one cart left. While self carts len is not equal to 1 self tick. Oh, but we have to reset it. we have to reset everything. Oh, no, we don't care about time. We don't care about time. We just care about the location of the final cart. Right? So then we're going to say create output format, bang, x comma y of cart pos x 0. I think it's 0 and 1, right? Yeah, I used a tuple. Cart pos 1, right? And then we just have to grab it. Cart equals self carts 0 pos. Right, we can just grab the pos. Oh, first. Self carts first unwrap pos. Unknown. So I got that wrong. There's no method name first on, oh, there. I wonder if it's easier just to say cart 0 pos. Because I think that's what my brain was going for. All right, so cargo run. That's not a good sign. Smab UK says, wouldn't your output be the same as in part 1? Well, not if I continue running it, right? Because I see what you're saying. Yeah, no, I'm not going to print out the first crash. I'm going to print out the position of the final cart. Full Stack Live is now keeping an eye on the Mad Science Lab. Thank you, Full Stack Live. Not the value, the code to display it. Oh, what did I do? Oh yeah, I was pulling out. So self-tick was returning the tuple XY. Oh, I see what you're saying. Maybe I could just do this XY. And I can do XY here. Yeah. Thank you. That does look a lot cleaner. All right, now we have to figure out why the carts aren't crashing. So we're going to go to the test input, and we're going to use the test input from the example. Right there. So blow that away. Oh, that was the other thing. I guess I forgot to hit copy strongly enough. All right, so here's our test input. Let's go back here. There's read lines. So we can do this. Actually, what we can do is this. And then try running that. Yeah, it's running forever. So I'm not pulling the carts out proper. Oh, I'm not pulling the carts out at all. I never implemented that part. So I'm adding them to the crash lists. But now, I want to remove them from the crashed array of crashed vector, but I want to move them from back to front. So let's make this a B tree set, and that way the crash will be in order, and then I can just remove them from the opposite direction. Right, I can say for C in crashed dot iter rev, and that's just going to be I thought it would be usizes. And I was just going to say self carts remove C. I should probably use I because that's what I was using for the index. Oh, that's why I didn't import it. So if we go back down here now, I should be yes. Oh, it's a reference to usize. So like that. I still have a warning. Oh, now I'm not using hash set. Okay, let's see if it runs. It comes up with 6.4. Is that the same answer as we got, or they were saying it was? 6.4. Okay, I think we have it then. All right, so we can fire up Bacon again. Let's remove hash set. And then run it. And then go back here and switch these around. 8490. So I got an answer now. Hopefully it's the right one. Yay, that's the right answer. Okay, I'm pretty happy. Switch over to Clippy. Everybody's happy there. And yeah, now we can pull these extra lines out. Oh, I got 2 stars from SMAP. Thank you. Bum bum bum. I think that should be good enough, right? We got the answers. We got everything going. That means I think we're ready. Git status, git commit -am. Oops. Commit -am 2018 day 13 part 2.